Warning: this video contains some actions that may not be safe. Please be cautious, and we claim no responsibility for any injuries obtained from building this device.
Hey guys, in this video we're going to show you how to make these awesome teeny micro quads that we designed. They're extremely durable, like really durable. We've dropped them from 150 feet and they survive. They're fast, you can adjust the sensitivity, and you can build them yourself. What could be cooler? They use 3D printed frames, the SciSky 32-bit flight controller, okay, so parts-wise, you're going to need a decent amount of parts for this one. And okay, you're going to need a glue gun, a black Sharpie, and a red Sharpie. You're going to need, of course, your micro SciSky flight controller. You're going to need a scraper tool. You're going to need a bunch of solder. You actually don't need too much for this, but this is great solder. It's like a pound, you never run out. A solder remover or solder sucker. Just in case you make a mistake, this can be very handy to suck up some solder off your board. Gonna need a soldering iron. Make sure this has a relatively fine tip because what we're gonna be doing is extremely detailed soldering. 2 small zip ties, but I get some more because you're probably gonna mess up with these and you're probably gonna have to get some more, so I have 4 of them here. You're gonna need one of those little Arduino jumper cable things here. You're gonna need this to short 2 terminals on your board to flash your firmware. You're going to need a micro USB cable. You're going to need 4 micro JST 1.25 female connectors. And 4 micro JST 1.25 male connectors. These will be used to connect your motors to your flight controller. You're going to need a pair of wire strippers. You're going to need a female LOSI connector. This will be used to connect your battery to your flight controller. You're going to need a Turnigy Nanotech battery, and this is a single cell battery, and you want between 200 and 300 milliamp hours. I wouldn't go above that or below that because you either won't have enough flight time or you won't be able to lift it. You're going to need 4 7mm motors. You're going to need some Hubsan replacement propellers. Going to need some heat shrink tubing. For this, you're going to be using the smaller sizes, but it's good to have a selection because it really depends what type of wire you're using or what type of wire comes connected to your motors. If it's thicker, you're going to need thicker tubing. If it's thinner, you're going to need thinner tubing. You need a pair of wire snippers. You're going to need a pair of needle nose pliers. It's helpful to have a helping hand. You're going to need a teeny bit of masking tape to hold parts in place while you solder them. You're going to need a multimeter. Analog will work for this because you're not actually measuring, you're just making sure 2 terminals aren't shorted. Safety glasses. You're going to need a top plate. This is 3D printable and available on Thingiverse. We'll also be selling them on eBay by the end of the summer because I know all you people out are requesting to purchase some of our stink grenade cases, so we're going to start selling some of these. You're also going to need a bottom plate here. Like your top plate, this is flat, except your bottom plate has some landing gear stubs. You're going to need 4 spacer pegs here. And these will be used to space your top plate and bottom plate. Hey guys, so here we are in the lab. The reason we're in our lab is because it's actually our garage and it has great ventilation. Make sure when you're soldering you have great ventilation, because otherwise you will be inhaling a bunch of fumes. So for this step, we're going to be soldering up all 4 of our motors to some of our male micro JSTs. First, what we're going to want to do is take all 4 of our motors here and our wire strippers or wire cutters, because they both have cutters on them, and we're going to want to take off a little bit of length off of the end of each of the motors here. So you can just bunch them together and then take their little end bits here. Then you can do the same to your micro JSTs. Don't cut them too short. You still need a little bit of length, so you're going to want to cut these to about 2.5 inches here. Now that you're done with that, you can strip off about 1/4 to 1/2 inch off of each of the ends of all of your male micro JST connectors. Now you can repeat the same process for the motors. Okay, there you go. Now that you're done with that, you can take your heat shrink tubings. They should look like this, and they should be somewhere around that fat. You're going to want to cut this long stick into 4 pieces, and then you're going to get little bits that look like this. I'm not going to worry too much about color because I can always just look at the wire here, not so much of the heat shrink tubing, but if you happen to have the proper colors, you can just use those because it looks a little bit better. Take one of your heat shrink tubing pieces and slide it over each of your motor wires. And then you're going to want to take your micro JST, and for the clockwise motors, which are the ones using red and blue wires, you're going to take the red micro JST and twist that to the red wire. And the black micro JST, which will twist to the blue wire. You'll see it's actually quite long here. You have a bit excess wire, so you can trim that down so you only have a little bit of wire there. Now that you're done with this motor, you can do them to the rest. For the counterclockwise motors, which use the black and white wire, the white is positive and the black is negative. So the black is going to go to the black and the white's going to go to the red. Okay, now that you have your heat shrink coatings on your motors and they are wired up to your micro JSTs, it's time to solder them. For this, you're going to need your helping hand. What you're going to want to do is you're going to take one of your motors here and you're going to clip both of the wires into one of the little alligator clips of your third hand. You're then going to want to take your soldering iron and your solder, and what you're going to do is put your soldering iron on one side of the wire and your solder on the other, and get the wire hot enough to melt the solder, and then run that over a few times so you have this really thin layer of solder. That'll make sure that the solder is completely fused to the wire and that you're not using too much. You're going to want to do this for all the motors. Okay, now what you're going to want to do is take your soldered motor connections here and you're going to want to bend them towards one side so they don't stick straight up like they do here. And you're going to do that to both sides, and then you're going to want to take your heat shrink tubing and slide that over. And you're going to hold that together and heat gun it. Your heat shrink tubing should melt and insulate your wires, and you want to repeat this step for all your motors. Okay, now that you have all your motors wired up, it's time to move on to the next step. Okay guys, so for this next step, what we're going to be doing is we're going to be using our Sharpies and marking positive and negative on these micro JST female connectors because it's just handy just to know so you don't mess up when soldering, because that can be very hard to reverse. So what you're going to want to do is take one of your motors and one of your male micro JSTs and plug that into the female. And you'll notice one side's red, one side's black. On the side that's red, you want to put a red dot on the female micro JST. On the side that's black, you want to put a black dot on the side of the micro JST. And you want to do this for all of your micro JST connectors. There you go. Now that you're done with this, we can move on to soldering up our micro SciSky. Okay, now it's time to start soldering up your SciSky board. You're going to need your SciSky board and your low-C connector. So I have cut and stripped this low-C connector down to about 1.5 inches. And as you can see, the metal is exposed at the end. That's going to be going through these two holes here right next to our micro USB. One's labeled G and D and the other's labeled VIN. G and D stands for ground, VIN stands for voltage in. The red is going to go to voltage in, so VIN, and the black is going to go to ground, G and D. So you can thread this through. Once it has been threaded through, double check that it's done properly because you will fry your board. It does not have polarity protection. Just double check that it's in the right way. Mine is, and then you can take a piece of tape and run that over the micro USB port to secure it in place. Just like that. Now you can flip your micro SciSky over and you can see the wires coming out through the other side, and you're going to want to trim those off a little bit because you don't want them extending so much because that could cause a short circuit. Okay, now that those are trimmed, you can add a dab of solder on each of those little gold dots. There we go, just like that. Now you're done with your low-C connector. You can move on to soldering on your micro JSTs. Okay, for this step, we're going to be soldering on our micro JSTs. This will allow us to connect our motors and disconnect them if they happen to break. Since you have labeled your micro JSTs with one side black, one side red as positive and negative, you'll notice that there are 4 sets of holes that should fit perfectly with your micro JSTs here. And if you look really closely, you might need to use a magnifying glass because it's really small. One side says positive under each little hole. And that is going to be where your positive side is facing. Pop in your micro JST, double check that it's facing the right way because it is a really big pain to have to desolder these things. So yes, that side says positive. It says S3 positive, which means motor 3 positive. You're going to want to pop that in and then solder it. If you'd like, you can take a little piece of your masking tape and tape it in there so it doesn't fall out. And you can solder it up. Take your time on this. This is extremely challenging. I would actually suggest putting a super teeny dot of solder on your soldering iron and then dabbing it on, and if you don't have enough, just slightly sticking the solder onto it. It might even be a good idea to cut off a length of your solder because it's kind of hard to maneuver this 1-pound ball here. So I'm going to skip over this instead of putting it in fast motion because this takes a very long time and you should take your time and not worry about getting this rushed because you do not want to ruin your flight controller. Okay, now that you have your micro SciSky all soldered up, it's time just to double check that all your soldering has been done properly and that there's no shorts. For this, you're going to need a multimeter and your micro SciSky board. What you're going to want to do is set your multimeter to an ohm setting because we're going to be testing resistance. I'm going to set it to 2 kilo ohms. And then you're going to want to take each of your multimeter probes here and hold them up against each solder joint on your micro SciSky. So as you can see, when I put my probes together, the resistance reaches 0. So what we're going to be doing is we're going to be testing each of the connections on our micro JSTs to make sure that they're not shorted. So we're just going to touch them to each of the little solder dots here. There we go, my number didn't reach 0 at all, so that means that they are all good. None of them are shorted. If one happened to be shorted for you, you want to completely desolder your micro JST if you can't see the short and resolder it. Or if you can see the short, you can try to clean it up with a wire brush or wire snippers or a little pick tool, but that is still extremely challenging. So now that we are sure all of our soldering's good, it's time to hot glue this up to protect the connectors. Okay, to cover up your connectors with hot glue, all you're gonna need is your hot glue gun and your micro SciSky, and you're just going to add a dot of hot glue under each of the micro JSTs and LOCs. Just like that. And then once you're done adding your dot of hot glue, what you can do is you can just press on it with your finger, make sure it's flat. And then repeat that for all of your micro JSTs. Okay, just like that. Now what you can do is you can add another dab of hot glue on top here next where your LOC connects to your board here. And then you can add another dab where your LOC connects to your LOC wires here. So just right around the LOC connector here. This will ensure that this LOC connector doesn't get damaged there. Okay, now it is time to flash your firmware. So what you're going to do is take your micro SciSky and your micro USB and plug it in. Don't plug this into your computer yet. Now you're going to want to take a piece of tape and you're going to want to tape down the front of the micro SciSky. The front is indicated by the little arrow pointing forward. Okay, now that you have that done, you can open CleanFlight. And what you're going to want to do is hold your two ends of your jumper cable here to some dots on your board. One is shaped like a triangle and one is shaped like a teeny weeny donut. So what you're going to want to do is hold each end of your jumper cable to each one of these dots and hold them like that while you power them up. Make sure you are in the firmware flashing section of CleanFlight. So try to hold it like that, and you can plug it in. Then you're going to choose firmware. Choose Alienware F1, then click Load Firmware Online. There you go, and then you can say Flash Firmware, and it should say flashing. Make sure to hold this all the way through. Boom, there you go. It says programming successful. You can then pull that off. You can untape your SciSky, and then you can unplug it, and your firmware is flashed. The reason we're doing this now is because you want to flash your firmware before you put on your top plate and start assembling the frame, because you can't hold those little terminals together while your frame is on top because it'll block you. Now we can work on assembling our frame and mounting the flight controller to it. Okay, now it's time to mount your flight controller onto your bottom plate. To do this, you're going to need 2 zip ties in your bottom plate. You want to thread one zip tie through one of the slits on the side. And out the other slit. Just like that, and then do one on the other side, just like that. Now you can place your flight controller in the center. It does not matter which way it's facing. And you're going to want to zip tie that. Make sure to have your antenna above the zip tie. Your antenna is that little red wire there, because if you get your antenna pinched under, it is a big pain to have to pull it out, and you could risk breaking it, and it's extremely hard to resolder. So you can tighten that up and then snip the ends. There we go. Now your flight controller mounted, it's time to install our spacers. Your spacer pegs look like these, except they may be in a different color. These are blue ones. If you'll notice, there's 2 sides. One side is really smooth and one side is a little bit rough. That's just because they were printed like this, and that's just one of the downsides of 3D printing. Make sure the rough sides are on the bottom so you don't see them. Makes it look better. So what you're going to want to do is pop in all 4 spacers into all 4 of these holes here. You're going to do that by taking some form of wooden board or table edge, putting the spacer peg slightly into the notch, and then on the edge, pushing it in. You should hear it pop. Don't be worried if one of your spacer pegs breaks, because if you own a 3D printer and you 3D printed this frame, you can always print another. They only take about a minute to print each. And if you bought a kit from us, we always ship extras. Now that you have your spacers in, it's time to install your motors. So if you notice, there's two types of motors, one with red and blue wires and one with black and white wires. Red and blue is clockwise and black and white is counterclockwise. The reason there's two directions of motors is so your quad doesn't continually spin, because each of their gyro effects counters each other, so your quad can fly straight. The motor numbering on this is motor 1, this is motor 2, this is motor 3, this is motor 4. So motor 4 is clockwise, so what you're going to want to do is take your clockwise motor, and if you'll notice there's some dimples here, and there's little slits for your wires to come through. Put that motor in, and then wrap your wire around the peg. Here. And then plug it into the nearest JST connector. The front of your quad is defined by the little arrow here on the front of your flight controller that points forward. So that means that this is motor number 4. And motor number 2 here will be counterclockwise. If your motors pop out, don't worry, there's going to be a top plate to hold them in place. The fitting is just a bit loose. Motor 3 is counterclockwise. And motor 1 is clockwise. Now if any of your motors have fallen out, you can just gently rest them back in there. And now it is time to install your top plate. So your top plate has an arrow facing forward on the front here, and that should align with the arrow facing forward on your flight controller. So make sure they're both facing the right direction, because I've also labeled the motor numbers on your quad arms here very lightly, and that is so you can easily install your propellers. The top plate should just pop over your motors here, and you should have your spacer pegs. They should just fall directly into here. You're just going to do this on the front, and once again, you're going to take your board and pop those pegs in. Just like that. Now you can repeat for the other side. Just like that. Now you'll notice that your low-C connector is hanging out the back here. And you'll also notice that there's a little rectangle slit on one side of your top plate. What you want to do is take your low-C connector, and it should slide conveniently in there. Make sure that the side of the low-C connector with the hole is facing downwards. And this is so you can easily plug in your battery. And now it's time to mount our propellers. Motor number 4 is clockwise, so the propellers wants to spin this way. So we are going to use the blue propeller labeled A. Don't shove the propellers down too far, because otherwise they'll either hit your pegs or grind on the frame. If it goes down too far, just pull it up a little bit with some pliers. Just like that. Now you're going to put the other blue propeller on the other side. Now for motor number 1, it's going to want to spin clockwise also, so you're going to put black propeller number A. And then on number 3, you're going to put black propeller B. And there you go. Okay, now you're going to want to get a rubber band, for example this one. And if it's long like this one, you're going to want to fold it over itself. And what you're going to do is, if you'll notice, there's 2 slits on your quad here and here. You want to take it and thread it through here. This will be used to mount your battery and hold it in during flight. So now we can get a battery and slide that in. Okay, and there you go. Now you're done assembling your micro quad. Now what you can do is go over to your computer and start programming it in CleanFlight. That will be a part for our next video. Thank you guys for watching. Hope you liked this video. Make sure to give us a like and subscribe. And if you have any other video suggestions, leave it in the comments below.